Okay, so we're doing scatter plots. So your objective today is I can describe the patterns of clustering, linear association, and nonlinear association. So your sub-objective is to understand positive, negative, and no associations, identify linear and nonlinear associations, and understand positive and weak clustering. Okay, so everybody should have their notes. Everybody has a pencil. Everybody's ready to take notes? Okay, so a scatter plots are graphs that use points to display numerical data with two variables or bivariate data. Bivariate is two variables. Okay, your x and your y. Scatter plots can help determine if one variable has an effect on the other, or if there are overall trends, patterns, or associations between the variables. So let's look at this graph below. It says Susie went to the mall and surveyed shoppers to see how many items they purchased and the total amount of money they spent at the mall. She created a scatter plot below. So notice it's two pieces of data. The number of items they purchased versus the amount of money they spent. Okay? So first we need to see how many shoppers she surveyed. Well, all you have to do is count the points. When you count the points, you would see that she surveyed 16 shoppers. Okay? And then looking at the data, it says, does the number of items purchased seem to have an effect on the amount of money a shopper spent? Well, if you look at the number of items, you see that as the number of items is increasing, so is the amount of money. Because someone who purchased 10 items spent between $180 and $200, probably $190. Somebody who bought one item only spent $40, or somebody who bought two items spent $20. Okay, so the more as your X is increasing, you can see that your Y is increasing. So that means it has a positive association. Okay. So overall, it seems that the people who bought more items also spent more money. Okay, so now we're going to talk about positive associations, negative associations, and no association. So everybody see the graph right here? Okay, does everybody see how as the line is increasing? So you see as the Y is increasing, so is your X, because the points are going up. Okay? So when you have two variables have a positive association, when the variables move together, for example, as one variable increases, the other variable also increases. So for a negative association, as you see, as your Y or as your X is increasing, your Y is decreasing. So two variables have a negative association when the variables move in opposite directions. For example, as one variable increases, the other variable decreases. And finally, no association is when you have two variables have no association when the change in one variable has no effect on the second variable. An example would be your height and your eye color. Do they have any association on each other? No. Okay, so describe the type of association you expect to see between the following. A, the hours a person studies and the number of states they visited. Do you think that'd be a positive, a negative, or no association? The hours a person studies and the number of states they visited.
It's opposite.
It would be no association. Because the number of hours Monnier studies has no bearing on the number of states she's seen, does it? If you spend 5 hours studying, does that mean that you've seen 5 or 6 states? No. You can spend 0 hours studying and have gone through all 50 states. So B, the hours a person studies and their grade on an exam. Do we think that has a positive? Yes, that is definitely a positive association. Because the more time you spend working on a subject or material, the better your test score is probably going to be. As I say, probably. But so the hours a person studies and the hours they spend watching TV. Yes, it is going to have a negative association. Okay, so if a straight line can be drawn through, if a straight line can be drawn to follow the overall trend of a scatter plot, it is linear. And it's not that you draw a line to match all the points, is you draw a line through the center of the points. Okay? It would be linear. If the points of data are close together, the association is strong. And if the points of data are widely spread, the association is weak. So label each type of association, the strength of the association, and whether or not it is linear. So number 1, I could draw a straight line through this material. Okay? Granted, I can't draw a straight line, but I can draw a straight line, if you get my drift. Yeah. So that means that this is a linear association. As the x is increasing, so is the y, so that means it's a positive. And the points are close together, so that means that it's going to have a strong association. So I have a positive association, a strong association, and the line association is linear. Okay? As long as you can draw a line through the center of the data that makes a straight line, it would be linear. Oh, shoot. Number 2. So what do we think number 2 is? Can you draw a straight line through that material? Well, if you go through the center of it, yeah, you could draw a straight line. But are the points close together or are they far apart? They're far apart, so you think that's strong or weak? Weak. Do you think it's a positive or negative association? It's positive, yeah. So it's a positive association. The association is weak because the points are spread apart, but you can draw a straight line through the center of the points. So what about 3? What do we think 3 is?
You can't draw a straight line.
No, so that's nonlinear, isn't it? Is it positive or negative?
Negative. Right.
Well, so positive means, as you're reading it from left to right, the points are going up. So is it positive or negative?
Yep, positive.
It's positive. Are they close together or are they far apart?
Close.
So it means it's strong or weak? Strong. So there you go. Positive, strong, nonlinear. So everybody do 4, 5, and 6 on your own. Okay, so Orion, on number 4, what did you say? Is it going to be positive or negative?
Negative.
Is it strong or weak?
Strong.
And is it linear or nonlinear?
Linear.
Okay. So, Renaja, what about 5? What do you think? Is it positive or negative?
Negative.
Is it strong or weak? And is it linear or nonlinear? There you go. Negative, weak, and nonlinear. 6. What do we think 6 is, Mr. Wyatt?
Non-linear, and I don't know.
So what was if it wasn't a positive or negative, what would it be? No association. So this is no association. It's weak because they're not close together, and it's nonlinear. So 7, describe the type of association you expect to see between the following variables. And we're talking positive, negative, or no association. So a person's height and a person's shoe size. So as a person grows, are their feet going to grow? So is that a positive or negative association? Is it a positive association? And all you need to do is write down positive. So, the number of letters in a person's name and a person's IQ. So, is that is it a positive, negative, or no association? No association. Just because Renaja has lots of letters in her name doesn't mean she has a high IQ, right? Doesn't mean that, let's see, Orion only has 4 letters, right? So that if you use that association, is that saying that he has a low IQ? No. Okay, so that's no association. So what about the number of absences a student has in their GPA? Negative, yes. Okay, so 8 through 10, it says match each scatter plot with its possible description. So I'm going to let you do 8, 9, and 10 on your own, and then we're going to come back and go over it. Okay, Kimberly, number 8, what do you think that is? A, B, or C?
B.
B. So the size of a home and the cost of monthly utilities for the home. So as the size of your home is increasing, should your monthly utility bill increase? Yes. Yeah, so 8 is a negative association, right? Mm-hmm. So which one up there do you think would have a negative association? C. Yeah, the altitude of a hiker and the total oxygen levels in the air. Does that make sense? Kimberly? Because the further you go up, like if you're hiking Mount Everest, people, when they get up to the top, they have to start wearing oxygen masks, don't they? Yeah. Okay, so A would be C. Now, 9 would be what? B. 9 would be B, because as the size of your home is increasing, obviously your monthly utility bill is going to increase. And then A is the temperature outside and the total gallons of gas sold at gas station. So I don't think that if I need gas, I'm going to let the temperature outside determine whether I get gas or not, right? I probably don't want to get gas if it's 26 degrees outside. But if I have no gas and I got to go someplace, I'm going to get it anyway, right? So 10 would be A, because it's no association. Okay, so now we're going to go into constructing scatter plots. So we're going to construct the scatter plot and describe the patterns. So once again, we have to know positive, negative, and no association. We have to identify linear and nonlinear associations. We have to understand strong and weak clustering, and then we have to know how to plot points on a graph using a table. So this is no different than plotting a point with an ordered pair. You have your X and your Y, and you plot your points. Okay, so we're going to construct a scatter plot. It says Jared's basketball team stood at various distances from the basketball goal and counted the number of baskets they were able to make in 30 seconds. The distance each person stood from the goal and the number of baskets made is shown in the table. So we're going to have to make this table, okay? So my top line on the table is going to be my X, and it's going to be the distance from the goal. Okay, so everybody needs to label their X as distance from goal. So everybody needs to label their X as distance from goal. And then you can label your Y as the number of goals made, which is the bottom letter. So these are ordered pairs. Okay?
I said gold.
And then we're going to put numbers on our X and our Y. So we're going to skip a line. Obviously, we start at 0. We're going to skip a line and then write 4. Okay, so we're going and then we have 8, 12, 16, 24, and 28. So right here would be 2. This would be 6. In between 8 and 12 would be 10. In between 12 and 16 would be 14, and so on. So you need to skip a line. And then on the Y, you would skip a line and write 2. Skip a line and be 4. Skip a line 6. Skip a line 8, 10, 12, and 14. I had a hard time with the slide. So 8 is supposed to be right here. When I graph my first point is at 14 and 4. So I'm going to come over here between the 12 and 16 is 14. And then I'm going to go up to 4 on my graph, and I'm going to plot a point. Okay? So my second one is 25 and 6. So I'm going to come over here to 25, which 25 is going to be between, the line between 24 and 28 is 26. So 25 is going to be smack dab in the center, and we have 6 baskets. Okay? And then we have 27 baskets, which is going to be in the center of the line before 28, and we have 7 baskets. Then Mark was 15 feet away, and he scored 11 baskets. CJ was 26 feet away, and he scored 6 baskets. Oops. Kevin was 16 feet away and scored 6 baskets. He was 16 feet away and scored 13 baskets. Wade was 15 feet away and scored 12 baskets. Kyle was 26 feet away and scored 8 baskets. And Chris was 16 feet away, which is right here, and scored 14 baskets. So one thing I want you to notice is that you have clusters. So you have this is a cluster, this is a cluster. Does everybody see the clusters here?
Yep. Mm-hmm.
Okay. So it says use the data in the table to make a scatter plot, which we already did, then answer the questions that follow. What type of association do you see in the scatter plot? So what's happening on my X? It's doing what?
Going up.
It's increasing. So what's happening to the points? They're decreasing. So it has what kind of association? Has a negative association. What else do you notice about these plots? Are they grouped?
Yeah.
Yeah, so you have this group and this group. Okay? And then you have this one right down here. Okay? So you have a negative association, and the points seem to have a gap between them. There's also one point that doesn't fit the pattern of the rest of the data. So these are your groups, and then this is your outlier. So these questions on number 2 go with the graph. Okay, so you have to look at the graph on your paper. So when you look at the scatter plot on your paper, we're going to label these questions as true or false. As the distance from the goal increases, and the distance from the goal is your X, as it is increasing, the number of baskets made are decreasing. Is that true or false?
Yes.
Yes, it's true. Because if you look at it, you can see that.
I just said wait because that made no sense. You said, is that true or false? And he said, yes.
Yes apparently means true. So B, as the distance from the goal decreases, okay, so that means as the number of baskets made increases. So look at your graph. If they're standing closer to the goal, do they have more shots or less shots?
More shots.
So is that true or false?
True.
Except for the one guy, Jared. So, as the distance from the goal decreases, the number of baskets made decreases. Well, that's false because we just said as the closer they are to the goal, the more baskets they made, right? So that's false.
Yes.
Okay? Okay, so looking at your graph still, you have Jared, he's an outlier. And that is a point that does not fit the overall pattern or trend of the scatter plot. And that is, they're known as the outlier. So we just said, who was the outlier?
Jerry.
It was Jared. And the reason why he was an outlier is because the number of baskets he made was much lower than the rest of his teammates who stood at a similar distance from the goal.
Oh, wait, never mind. I see it right. Can I just write Jared?
So, and then you have clustering. Clustering occurs in a scatter plot when there are distinct or separate sets of points or groups of points. And we circled those, right? There were definite groups. That's called clustering. So why do you think clustering occurred in the scatter plot above? Well, it occurred because it seems that a group of the players stood closer to the goal, and then a group of the players stood further from the goal. Okay, so the population of 10 cities and the number of elementary schools is as shown in the table. Make a scatter plot of the data. Okay, so let me ask you a question. What is the X? What is the X?
Population.
Population. So I'm going to write up here, I'm going to write X above population. What is the Y?
The number.
The number of elementary schools. So what I need you to do to make sure that we all know how to plot is I need you to plot all of these cities' population and the number of elementary schools. So, for example, Lawton has 76,000 people and 19 elementary schools. So, it's not going to be exact, but it's going to be right in here between 70 and 80. And then they have 19, so it's going to be right about here. Okay? So, go ahead and do the rest on your own, and then we'll come back.